how STL implements the less than operator for stack and other abstract data types. So if we go to the documentation and look at the comparison operators, so it says that compares the contents of underlying containers of two container adapters. That means the adapter which is on the left hand side of the comparison operator and on the right hand side of the comparison operator. The comparison is done by applying the corresponding operator to the underlying containers. So what is an underlying container? If you look at the documentation of stack, it says that it is a container adapter. So it is basically not a storage container, it is a container adapter. An adapter does not use its own storage, rather it uses storage of some other container. Now by default it uses and if we see that the container is passed as a template parameter, so when we are declaring a stack object we can mention which container do we want to use. By default deck is used, but we can use any other container which supports the back function, push back function and pop back function, right? So if a container like list, vector, deck, so supports these three operations, that container can be used with a stack. So if we just want to see how vector implements, which is one of the underlying container, it implements the less than operator, we can look into its documentation, go to the comparison operators, and here it says that checks the contents of left hand side and right hand side. uh, if we particularly look at less than operator, less than equal to, greater than operator, and greater than equal to operators 3 to 6, it says that compares the contents of left hand side and right hand side lexicographically. The comparison is performed by a function equivalent to this function. So what do we mean by lexicographical comparison? It is basically the same comparison that we do in let's say our contact lists, or in when we are sorting the files or folders. So if we have alphabetical data, string data, we know how do we sort it, right? So for example, if we have A, B, C, uh, D, E, and A, B, B, right? If we want to sort them, we know which of the string comes first. So for sure D comes later because D it comes after A. So first we will have A, one of the strings from ABC and AAB. If we compare these two, we start the comparison from the first letter. So A is equal to A, we cannot decide on it. Then we compare the second letter, B is greater than A, so that means A is smaller than AB. Based on just these two letters, we can decide which of these two strings comes first. So first B would appear, and then second we would have A, B and C. And if we compare A, B, C and D, E, the comparison is decided on the first comparison. When we see that A is smaller than D, we know that A, B, C would come first. So we do not need to compare the rest of the letters. So the third would be D, E. So this is lexicographical comparison. If you're confused about it, just visualize your contact list in your phone book or on your computer and just imagine how strings would be sorted there. So that is lexicographical comparison. If we talk about stacks, let's say we have a stack in which we have values 1, 2, 3, and another stack in which we have values, let's say 1, 2, 4. The comparison starts from the first value that is stored in the container. So in STL we are using tag or vector or list as a container. So the comparison would start from the first value that is stored in the container. So in this case it would be the bottom of the stack. So if we compare 1 with 1, we cannot decide because both are same. We compare 2 with 2, we can still not decide because both are same. And then we compare 3 and 4. As 3 is less than 4, so we say that S1 is less than S2. if we have, let's say, 1 2 and here we have 1 2 3. So in this case we compare 1 with 1, 2 with 2, and now stack 1 is finished, is ended first, so we say that S1 is smaller than S2. Similarly, if we have, let's say, 1 2 3 and 1 2, so we compare 1 with 1, 2 with 2. Now as stack 2 is finished, so stack 2 must be smaller than stack 1. So this is how we use comparison operator lexicographically in STL in stacks. And if you want to implement the less than operator or greater than or less than equal to any inequality operator, we can look into the documentation. The documentation says that these are non-member functions, so that means we have to implement these functions out of the stack class, right? So we would have a function which would take two parameters, return a boolean operator less than, and then we would have two stacks. They would be passed as constant objects by reference. And we have to mention that we are using templates. You can use class instead of type name as well. Now we need to compare left hand side with right hand side, right? So now it really depends how we are implementing the stack. So if we are using another container like list or vector, we can simply call their less than function, right? But if we are implementing our own stack, we are using our own storage, then it really depends what kind of storage we are using. Let's say we are using an array for storing values, right? So we have arrays. So this is for, let's say, left hand side, and then for right hand side we have also another array, right? And then we have some values like 1 2 3 and 1 2 4, let's say. Now we have to compare the values one by one, starting from the 0 index going till the top indexes, and we have to compare the values one by one. So we take two indexes, let's say left index and right index, right? We set both of them to 0. Left index is equal to right index is equal to 0, and now we can start comparing the values stored within the arrays. So let's say the values are stored in the data array. So we have left hand side dot data and right hand side dot data, and we just need to compare the values one by one. So we use a for loop, or we can use a while loop. So while left index is less than or equal to left hand side dot top, so we will, if all the values are same, we will go till the end of the array or the index where valid values are stored, that is the top index, and right index is less than or equal to right hand side dot top, right? So until these conditions are not met, we need to compare the values one by one. So we will only move ahead if both the values are same. So we only in that case we need to check the next index. So we check whether if data left hand side dot data left index is equal to right hand side dot data right index. So if they are same, we just increment both the indexes plus plus left index plus right index and continue. Now if the values are not equal to each other, then we would have two cases: left hand side dot data is less than right hand side dot data, or left hand side dot data is greater than right hand side dot data, right? So if it is less, we return true. If it is not less, that means it would be greater, we return false. So in that case, we can simply write return left hand side dot data left index. So we just look that value is less than right hand side dot data right index. That's it, right? So we'll get out of the function. But it might be the case that we have a stack on left hand side which has two values, and we have a stack on right hand side which has three values. First two values are the same, so we will get out of the loop. And now we need to check if left hand side is smaller than, so we will, when we will get out of the loop, we will only get out of the loop when we compare first value, they are the same, second value, they are the same. Now this condition would be false because left index would exceed left hand side dot top, right? So it would become greater than left hand side dot top, we will get out of the loop, right? So now we just need to check whether left hand side has more values, less values than the stack on the right hand side, and that would decide whether left hand side stack is smaller than right hand side stack. So we can simply return left hand size dot size is less than right hand side dot size, right? So let's say we have these size functions, or if we have a variable which stores the size like n, we can compare those variables or call the size function if it is supported by the stacks. Or we can have some other mechanism. We can also write something like that, right? Left hand side dot top is less than right hand side dot top, so it would also do the work. Now if left hand side has less number of values than right hand side, then we return true, right? But if right hand side has less number of values, then we return false. So this is how we would implement the operator less than function lexicographically for array based implementation of stack. It might be the case that stacks are implemented using linked structures, right? So if you recall in the earlier lectures, you can search for other videos in which we implement the stack using linked structures. So if we have implemented the link structures, the stacks using link structures, then it would be tricky. So let's say the stack on the left hand side, if you recall, we just keep the pointer of the topmost node, right? And then they contain the links to the next node. So we have 1, 2, 3, and then right hand side we have, let's say, 1, 2, and 4, right? So this is the simplest implementation. Of course, STL does not use this implementation, but let's say we have this kind of implementation. Now the issue with this kind of implementation is that if we want to implement the less than operator in the similar way as it is implemented in STL, then we have to start comparison from the bottoms of the stacks, right? So we will have to go through all to the end, and then we start comparing the bottoms. That is only possible if we use additional stacks. So for example, we take a left stack in which we push the values one by one, like 3, 2, 1. So we kind of reverse the stack, and then we have right stack in which we again reverse the values like 4, 2, 1. And now we can compare the values one by one and decide which of the stack is smaller. So this is one of the ways. Another way is that we deviate from the implementation of STL, and we say that we start comparison from the tops of the stack instead of bottoms of the stack, right? So this is another option, but in that case, of course, our results would be different from the results of STL, because we would be comparing the values from the tops of the stacks instead of bottoms of the stack. So let's go through both of the implementations. So let's say we have that same Boolean operator less than const stack t ampersand left hand side, and then const stack t ampersand right hand side, and we have this template type name or class team, right? Now let's say we want to implement the same approach that STL uses. Then we have to put the values of left hand side and right hand side into separate stacks. So we take two temporary stacks. So stack the left stack and right stack, and we put all the values from both the stacks into these temporary stacks. So we say we take a temporary pointer node t static temp. We initialize it with the top pointer of the left hand side dot top, and while temp does not reach the end, that would be represented by null ptr. So what do? We take the value pointed by this temporary pointer, right? We put it into the temporary stack, and then we move temp to the next node, and then temp to the next node until we reach the null pointer. So what do? We say that ls dot push temp dot val, right? So we'll push this value stored in the node to this temporary stack, and we move the pointer to the next node, right? And then we do the same for right hand side. So instead of left hand side, now we initialize with right hand side, and we say that push the values in the right stack, right? So all the code is the same. We initialize the temporary pointer with the start top pointer of the right hand stack, and we push all the values in the right hand stack into rs, the temporary right stack. Now we need to compare both of values in both of these stacks. So now the stacks are reversed. We compare the tops. If they are same, we move ahead, and we keep moving ahead until we reach either an inequality or end of the stack. So we say that while left stack is not empty and right stack is not empty, right? So until both of these are not empty, what do? We need to do the comparisons. So we say that if left stack dot top is equal to right stack dot top, only in this case we pop the values from the stacks. So left stack dot pop right stack dot pop, that's it, and we continue. Now if the values are not equal, then they are like the top of the left is less, either it's less than the top of the right stack, or it is greater, right? So in either case we return whatever the comparison is. So if left top is smaller than right top, we return true. So if this inequality is true, we return true. If left top is greater than right top, then would this inequality would result into false, and we return false. Now it might be the case that both the stacks have some values like 1 2 3, and then let's say 1 2. Now we compare 1 with 1, 2 with 2. Now stack on the right hand side is finished, and stack on the left hand side still has some values. So in that case we just compare. So if the left hand stack is empty, that means that left hand stack has lesser number of values than right hand stack, then we can return true, otherwise we return false. So in this case left stack is not empty, but the right stack would be empty, right? So in this case we should return false. So we just return if left stack is empty, right? Now how this would work, so let's say if left stack has 1 2, right stack has 1 2 3. So in the while loop we will compare the first values, then the second values, and then we will get out of the loop because left stack has become empty, right? When we come out of the loop, left stack dot empty would be true, so we would return true. In the earlier case, in the example above, so we compare 1 with 1, 2 with 2. Now right side has become empty, we come out of the loop, we check left side is empty. Now left stack is not empty, so we return false. So in this case we otherwise should have returned false. In this case we should have returned true. But what if both the stack has same number of values? So in this case, so 1 would be compared against 1, we will pop these values. 2 would be compared with 2, we will pop these values, and left side would become empty. But in this case we should return false because both the stacks are equal, right? So in this case we should have a check before this return statement that if left stack is empty and right stack is empty, if both of these stacks have become empty, then this means both of these stacks were equal, so we just return false, right? Otherwise we check whether left stack is empty or not, just as we did in the first two cases, right? So we need to put this extra check. Also, let's also review if we have done this correctly in the array based implementation. So if both the stacks would be equal, right, so we will get out of the loop, and left hand size would be equal to right hand side dot size, so both of these size would be equal, and inequality, this less than equal inequality, would be false. So for arrays it would work, but for uh, link structures we would have to put an extra check. Of course there can be ways to optimize uh, this approach, and you can think about it. Now the last approach that we discussed earlier is that we start the lexicographical comparison by comparing the tops of the stack. As we discussed earlier, that this would basically this would basically be different from the implementation that we have in STL. But just for exercise, we can do the same thing. So the signature of the function would remain the same. In this case, if we want to start comparing from the tops of the stacks, we take a temp left pointer, right, and a temp right pointer. So both point to the top nodes of the corresponding stacks. If their corresponding values are equal, we move them forward, and the rest of the approach is almost the same as in the case of arrays, just that we have pointers instead of indexes. So we will have two pointers, node t static temp left and temp right. So we will initialize temp left with left hand side dot top and temp right with right hand side dot top, and then similar while loop while temp left is not equal to null ptr and temp right is not equal to null ptr. We check if both the values are equal. So if temp left dot val is equal to temp right dot val, we move both the pointers forward. So temp left is equal to temp left dot next and temp right is equal to temp right dot next, and we continue the loop, right? And if temp left dot val is smaller than temp right dot val, we should return true, and otherwise the third case would be temp left dot temp tl dot val is greater than tr dot val, right? So we just say return tl dot val is less than tr dot val, right? So that's the case. Now if we will come out of the loop, we would have one of the three cases that both the stack had similar values. Stack 1 finished but stack 2 did not, or stack 2 finished but stack 1 did not. So left hand side and right hand side. So in case 1, both of the pointers would be null PTR, right? So temp L and temp R would be null PTR and we will get out of the loop. So in this case, what we can do, and also in the case when right hand side, left hand side is not equal to null PTR. Okay, let's deal them separately so we don't get confused. So we say that if left hand side is equal to null PTR and not left hand side, rather temp left is equal to null PTR and temp right is equal to null PTR, we return false. This would be the case when both the stacks have the same values and we come out of the loop. And now if this is not the case, we just need to check whether temp left is empty, right? Is null PTR. So if temp left is null PTR, we can return true. If it is not null PTR, then that means temp R would be null PTR. So we can just return temp left is equal to null PTR, right? So in this case, so for example, if it's this case, the second case, then temp left would be null PTR because of this statement, and we will come out of the loop because of this statement, and temp right be would be would not be null PTR, right? So in this case, temp L is equal to null PTR would return true and we would return true. And in the third case, temp L would not be null PTR and temp R would be null PTR. So in that case, we return false because in this case, stack on the right hand side is smaller than the stack on the left hand side. So I hope this explains the things. So if you have not gone through the implementation of stacks using arrays or using link structures, you can look into the videos that cover these concepts that I have uploaded earlier.